President, ladies and gentlemen, thank you very much. I thank the Royal Society of Edinburgh for hosting this meeting. I thank Michael for being my co-organizer and the organizing committee, the local organizing committee, Andrew Rinicky and Richard Morris for organizing this meeting, which in a way is unusual. I think interdisciplinarity is the sort of password these days for grant applications and stuff like that. But of course, people don't put their money where their mouth is. They just pay lip service to it. And I'm delighted that the Royal Society of Edinburgh has actually put this thing together because it is actually a rather important issue, if only because we all seek beauty almost 24 hours a day, whether in our homes or in our partners or in our work. Now, I am a neurobiologist, and I'm going to be talking mainly about the brain, in fact, exclusively about the brain. And I think one of the functions of the brain, a lot of functions you can ascribe to the brain, production of language, of movement, of seeing and hearing, but one of the primordial functions, which sort of covers all of these sub-functions, is the acquisition of knowledge. That knowledge is acquired to be able to take some action, of course, but the acquisition of knowledge comes first. So, to acquire knowledge about the world, the brain has got to somehow stabilize the world, because the world is sending disparate signals all the time to the brain, and somehow the brain has got to extract some kind of order from that world. And it does this on the one hand sensorially, as in the example of color vision, which I'll show you in a moment, and on the other hand, cognitively, as in the case of mathematics. And in between, I think beauty plays a significant role. So starting with color vision, the single most important feature of color is color constancy. In other words, the fact that the colors of surfaces and objects do not change when viewed in different illuminants. For example, if you were to view a piece of white paper in tungsten light, like this, or in fluorescent light, or outside on a rainy day, and measure the amount of red, green, and blue light, or precisely long, middle, and shortwave light reflected from it, you'd find significant variations, but you'll always see it as white. And somehow the brain is stabilizing that world and discounting, as Helmholtz would have put it, discounting the illuminant. Now, it does this by a simple process, which I'm going to just briefly describe to you, and this is the only sort of taxing part of my talk, which is if you take a multicolored scene, which bears a sort of vague resemblance to the paintings of Mondrian. This is an experiment of Edwin Land, and it's illuminated by three projectors, which, where is the... three projectors which pass red, green, and blue light. And the entire scene is made up of an arbitrary collection of arbitrary shapes, rectangles and squares. So an audience such as yourselves would be asked to look at a particular nominated square, such as, for example, this green one. And now, I am having difficulties these days with this computers. Just barely you can see it there. And make it reflect 30 milliwatts per steradian per meter square of red light, which I'll call unit, 60 of green light and 10 of blue light, and switch all three projectors on. This area will appear to be green, which is reasonable because it's reflecting twice the amount of green than of red light. Now, in the next and critical experiment, which, as I say, is due to Edwin Land, in Cambridge, Massachusetts. In the next experiment, you make the same area reflect 60 units of red light, 30 units of green light, and 10 units of blue light. And when you switch all three projectors on, again, the area is reported to be green, even though it's reflecting twice the amount of red light. And the reason for that is that whatever proportion of, whatever quantities of red, green, and blue light it's reflecting, the surround has got different reflectors. With, for example, when this area is reflecting 30 units of red light, the surround, which has a higher efficiency, surround defined as 7 degrees in all directions from here, which has a higher efficiency for reflecting red light, reflects more, and there is a ratio in the amount of red light reflected from the screen surface and from the surround, which is 0.75, which is identical to the ratio obtained when this area is reflecting 60 units of red light. The surround will reflect more, the ratio will remain the same. And the same is true for green and blue light. Now these ratios, through these ratios, the brain is able to dissociate itself from the continual change in the total amount of red, green, and blue light coming from a given single surface, and therefore, in a sense, stabilize the world. The ratios are brain ratios. There is no physical law which says that these ratios should be taken. They are dictated by an inherited concept in the brain, which comes into operation very soon after birth. And the result of the ratio-taking operation is the construction of constant colors. Now, when I say constant colors, I don't mean to say that when you view the screen patch under these conditions of illumination, under these, they are identical. No, the shade will change, but the color category will remain the same. So it is the result of that ratio-taking operation is the construction of constant colors by the brain. Colors do not exist in the world outside. They are constructed by the brain. Newton recognized this a long time ago in a quote which unfortunately is not repeated often enough. In his book Optics 1704, he wrote, "For the rays to speak properly have no color. In them there is nothing else than a certain power and disposition to stir up a sensation of this color or that," unquote. Now, you can mimic this experiment in a scanner, and you can get subjects to look at a Mondrian scene where the colors remain the same, but the wavelength composition of the light coming from each of these squares is changing, and look at the brain activity, which is measured through the changes in blood flow, because when brain areas are especially active, the cells in them respond more vigorously, and hence the metabolic requirement increases, and so more blood is channeled to that area, and you can capture this change in blood flow through the scanners. You can look at the activity produced by this pattern with its achromatic counterpart, and you find then that the activity is when people see these colors remaining stable even though the wavelength composition is changing, is in area V4. But when they see a pattern of black and white dots in motion, the activity is in area V5. They both activate the primary visual cortex. So this slide now shows you that the knowledge acquiring system of the brain is distributed. It is not localized in a single area, with color being the construction of color being localized in V4, of motion in V5, and there are many other specialized areas as well. The consequence of destroying these knowledge acquiring systems, V4 is localized at the base of the brain. If this area is destroyed, the consequence is an inability to see the world in color. The world is seen in black and white, and hence it becomes much more difficult to stabilize it, much more difficult to obtain knowledge about it, and that's the consequence of damage to area V4. By contrast, if area V5 is damaged, it's area V5 which is specialized for motion, and here it is damaged in a lady because of a venous occlusion. It's a large area of the cortex is damaged, but it includes area V5. The consequence is the syndrome of cerebral akinetopsia, or an incapacity to see the world when it is in motion. But actually fast motion, right? She could do slow motion, but not fast motion. So she has no knowledge, no dynamic knowledge of this world, but only static knowledge. So then the knowledge acquiring system of the brain is fairly distributed in different areas, which I will not go into, but it is, I think, worth repeating that one of the remarkable findings of the past 45 years in the visual brain is that about a quarter of our brains are visual, and it consists of many visual areas which are specialized to undertake different tasks. Now, I would like to come to the question of beauty next. Neuroaesthetics does not, and I'm really quite hoarse from repeating this because people take little notice of this. Only 2 days ago, 3 hours after I gave the lecture, somebody repeated something which I expressly denied. Neuroaesthetics does not ask the question of what beauty is, nor does it ask what art is. Neuroaesthetics is a much more limited topic, which asks what are the neural mechanisms that are engaged when we experience beauty. Now, this is as legitimate a scientific question as asking what are the neural correlates that are engaged, what are neural systems that are engaged when we experience color. It's just transposing a different area. This does not mean to say that we are not inspired by the way in which historians of science and philosophers of aesthetics have framed their questions. We are indeed, and we borrow from them. But the dialogue between us and them, the humanists, is very asymmetric in that we have a lot more to learn from them and a lot less to teach them. So with that said, I hope I have said it emphatically and clearly enough that we are not really seeking to explain beauty to anybody, least of all to ourselves, but only to understand something about brain mechanisms. Now, one of the nicest encapsulations of the problems that a person wanting to study the neural systems which are engaged when we experience beauty was done actually by Clive Bell, the husband of Vanessa Bell, about whom there was a documentary recently on the BBC. And he wrote in his book, Art, published in 1914, he said, if you can tell me what is in common in the Santa Sofia in Istanbul and the windows of Sharf Cathedral, the Mexican sculpture, the Chinese bowl, Persian carpet, and the frescoes of Giotto at Padua, and the masterpieces of Poussin, Piero della Francesca, and Cézanne, then you have essentially solved the problem of aesthetics. Now that's him saying it, and this list is his. He said, because unless, he added, I'm quoting him, unless all these things have something in common, when we talk about aesthetics, we gibber. Now, the neurobiologist can take that question, because no neurobiologist has actually summarized it quite so well, but frame it in a different context, say, is there a common neural mechanism involved when we experience beauty? And notice that Clive Bell's list, Clive Bell was an art critic, is largely visual, although he did speak of mathematical beauty and he did speak of musical beauty. We wanted to expand it. Historians of philosophers of aesthetics and philosophers in general speak, of course, of beauty in more abstract terms. They speak of beauty of poetry, of music, and so on, as well as visual beauty. So we wanted to include music. And secondly, we are aware of the fact, Clive Bell himself says, and don't blame me, you can blame Clive Bell for this, he said that the last person you want to go to understand the aesthetic emotion is to an art historian, because he knows too much. You want something primitive, something that the savages as well as children can appreciate. So we also excluded all art historians, painters, art critics, and so on. And we were not concerned with art, but with beauty, the experience, the neural mechanisms that correlate with the experience of beauty. So the connection between art and beauty having been severed by Marcel Duchamp when he sent his urinal to an exhibition in New York and threatened to sue them if they did not exhibit it. Now, so let me give you examples of the 21 subjects. This is an experiment I did with Hideaki Kawabata and then with Tomohiro Ishitsu, who will be talking tomorrow. Let me give you examples of things which most people found beautiful. I said not all of them, but most of them found beautiful. The experiments are based on each individual giving their ratings themselves. So there isn't a sort of a single picture that everyone found beautiful. Each one classified the pictures. They were shown into 10, and then we selected paintings from those which were beautiful, neutral, and ugly when they came back to the scanner. So the ones which they found beautiful, most found beautiful, are the odalisque by Ang. This was qualified, seen as beautiful by many, if not by all. The one which was considered to be ugly by almost all is the Lucian Freud, the benefits supervisor having a nap. Now this is a painting worth many millions of pounds if it were to come to auction. And it has got great artistic and painterly qualities. It projects truths about decay and decadence, but it was not experienced as beautiful, which is what we were interested in, that distinction between art and beauty. With music, almost all of them consider the next piece as beautiful. Which is, of course, the Adagietto from Mahler's Fifth Symphony, and almost all of them consider the next piece, which is the second violin concerto from Ligeti, as ugly. Again, this might have, for a musician, great artistic and musical qualities, but was not perceived as such by the subjects in our experiment. So if you look at the brain activity produced by looking at visual stimuli, you find, of course, that there's activity in the posterior part of the brain, the visual brain. If you look at the part of the brain which is active when people experience auditory stimuli, it's in the auditory cortex. If you look at the parts of the brain which are active with stimuli that are rated as beautiful, you find it occurs here in the medial orbitofrontal cortex, which is part of the emotional brain, part of the reward system of the brain. And if you look at the parts of the brain which activity which correlates with the experience of musical beauty, you find it's the same area, and so the two overlap in this region, which we call field A1 of the medial orbitofrontal cortex. Now, we can give, Clive Bell asked the question, never gave an answer, and there never has been an answer. We took Clive Bell's question and changed it, and we are asked, and we can now give an answer to his question, but only in the neurobiological context. So the question that we're asking is there any common mechanism in the brain where activity correlates with the experience of beauty derived from all sources, landscape, portrait, music, etc.? And our answer to that is yes, there is an area. It is located in the emotional part of the brain, the medial orbitofrontal cortex. And those of you who are worried about the question of statistics in brain studies and imaging studies, because the blood flow changes are of the order of 5 to 10%, can rest assured that this result is a result that the activity in the medial orbitofrontal cortex is a result that has now been repeated so many times that its statistical significance is very high. Now, one of the important questions that philosophers of aesthetics have asked is the following: can aesthetic judgment ever be quantified? You know, my experience, I say I love this, and you cannot be sure. How can I quantify it? First of all, I want to, let me just say that the Greeks have a word, kalon, which means both physical beauty and moral beauty, of which the Westmacott youth now at the British Museum is supposed to be one of the best examples. The beauty of his physique is balanced by the humility of his downward glance, and this is supposed to be one of the examples of the tight link between moral beauty and physical beauty. And it has been shown by Tsukura and others in the United States, actually, that the experience of moral beauty also correlates with activity in the medial orbitofrontal cortex. Now, you know and I know that people who are very handsome or very good looking are not necessarily very reliable. In fact, probably not at all. And I think that the fact that most of us will put greater trust, as has been shown in many studies, not by us but by others, put so much trust in the physical good looks is probably a reflection of the fact that both moral beauty and physical beauty activate or correlate with activity in the same part of the brain. Now, I think I just want to preface, before I go into the question of whether you can quantify aesthetic judgment, I want to make the statement which some of you may not like, but we could have a fight, that the only truths that you can be sure of are subjective truths. There are no other truths you can be sure of. So, to me, as a neurobiologist, this business of there are objective and subjective does not make much sense, because I can be sure that I find something beautiful, but I can't be sure that you find it beautiful. In fact, I can't be sure it is beautiful. It's only that I find it beautiful. I can be sure that I love someone, but I cannot be sure even if they love me in return. Right? So the only truth that you can be sure of are subjective truths, and this, I think, is probably also true of mathematics. Roger, I'm sure, is waiting with a gun to hit me. Now, and for those who would doubt that, this is the construction by Isia Levia. If you fixate in the center here, some of you will see very rapid movement in these rings, and I can assure those who see them that there is actually no movement there. It's a subjective experience, and this subjective experience correlates with activity in the part of the brain which is responsible for seeing visual motion. So now let me just go to whether the activity in the brain can be quantified. Actually, it can. So this is the area of the brain where activity correlates with the experience of visual beauty. And if you look at the relationship between the experience, between the blood flow and the declared experience of beauty, in other words, how beautiful people found something and how ugly they found it, the more beautiful they find it, the greater the blood flow here. Right? I just want to make 2 points here, because I know if this is left-right controversy about the brain, that both sides of the brain are active here. And the same is true of musical beauty. So the blood flow correlates, the change in blood flow, the intensity of the change in blood flow correlates with the declared intensity of the experience of beauty. And the same is true with ugliness. Now, the experience of ugliness correlates with activity in other parts of the brain, which I will not go to because I'm addressing the question of beauty, really. And you notice that I do not say that beauty causes activity there, because I'm really terrified of art philosophers and art historians. They're not quite as violent as those who use guns, as Michael was saying, but they can be pretty violent. So I say activity that correlates with the experience of beauty, which seems a more innocuous way of putting things. And again, here, the relationship is a parametric one. Now, this raises a very interesting question, which is of great importance to neurobiology. And remember that I'm a neurobiologist, I'm not a philosopher of aesthetics. So there is no area of the brain, of the cerebral cortex, which has got one output only. Most of them have upwards of 12 outputs. The question is, are all these outputs engaged when an area undertakes a task, or are they only engaged on a need-to-know basis? So this is a schematic representation of the primary visual cortex here, through which all visual signals enter the brain, and of areas in the brain which are specialized, and there are such areas, for the representation of bodies. So when you see, you look at a beautiful body, or one which you consider beautiful, you've got these areas here are active, and then something happens that this area correlates with the experience of this beautiful body. And when you look at the body which is ugly, you've got again common areas here, all right? But this time the activity correlates with, it's activity in the amygdala that correlates with the experience of this body. So something in here is filtering out the signals. And this is a very, very interesting question. of broad neurobiological significance. Now you can go to Edmund Burke and his definition of beauty, and you find that it consists of three parts: some quality in bodies, acting mechanically upon the human mind by the intervention of the senses. Quality in bodies is a physical property. The human mind I take to be the human brain. Now I know there are people who will be outraged by that and get up and say the human mind, the mind is more than the brain. I will not argue the point, I will concede. If they buy 50%, if they don't, I mean, will they buy it if I say that 50% of the human mind is produced by brain activity? Most of them I find accept that, but there is a sort of a group of resistant people who still hold out, and then I say, would you buy 10%? They say that's reasonable. I say, well, you take the 90%, I'll study the 10%. That's, for me, the mind. And the intervention of the senses is, of course, entirely the brain. So let us then get the computer, apply fuzzy logic, and prepare stimuli which are kinetic. They are made up of dots which move in different directions, and the same number of dots, same luminosity, same size, but different configurations. And this turns out to be a pattern that 21 subjects that we had in our experiment preferred to this one, which most of them thought was no good. Actually, there was no variation here. All of them thought this was no good, and all of them thought the first one was good and preferred. And if you look at the activity in the brain when they look at the preferred and the non-preferred stimuli, you find that there's activity in area V5, where the which is specialized for representing visual motion, and the activity there is parametrically related to the intensity of the declared preference. And also that the activity correlates with preferred stimuli, correlates with the activity in the medial orbitofrontal cortex. So we are now up to a point reaching in a very sort of sketchy way to satisfying the three pillars of the definition given by Edmund Burke of physical properties of bodies, activity of the mind, and intervention of the senses. It is perhaps useful to look at another kind of beauty, which was very prominent in the Scottish and the English Enlightenment of the 18th century, which is the separation of beauty from sublimity. Actually, this is a process that started with Longinus, a man of doubtful existence, a Greek of doubtful existence, a philologist, also therefore known as Pseudo-Longinus. And the difference between the two, much emphasized by Burke and Kant and Schopenhauer, is that the sublime is an amalgam, is a mixture of beauty mingled with horror, or pleasure from displeasure. And always grand on scale, like the Grand Canyon or a typhoon or the sea storm. And there are certain relationships that Burke pointed out between beauty and sublimity at the extremes. At the extremes, of course, something can be both beautiful and sublime, of which the supreme example would be the Pietà of Michelangelo at St. Peter's Basilica. But there is a relationship, according to Burke, between scale and pleasantness and beauty and sublimity. So if you are subjects, you'll find that there is an indifferent, almost flat relationship between sublimity and pleasantness, but an inverse relationship between sublimity and scale, because the grander in size, the more sublime it is, and there is also a relationship between beauty and sublimity. So if you get people, if you get subjects to look at stimuli which they themselves brand as being sublime on a scale of 1 to 10, where is the activity? You find that there's activity, and I'm not going to go into all these different brain areas because they're just anatomical things which are of interest to anatomists. For example, in the caudate nucleus and in the medial frontal gyrus here, medial frontal gyrus here in the putamen. But the important thing that I want to point out is that all these activities are parametric. In other words, they are proportionate to the declared intensity of the experience of sublimity. So it's a quantitative relationship. It's a rather powerful statistic. And if you look at compare the activity produced by beauty in green and sublimity, you find that they are different. So it's quite an interesting thing that something which philosophers of aesthetics have categorized as different. You know, it's a very unique thing, sublimity. It's horror mingled with beauty, pleasure from displeasure, fear, but fear of something looked at a safe distance, all right? Whereas, and small in scale, whereas and large in scale, whereas something beautiful is vast in scale. No, I'm putting it wrongly. Something which is beautiful, according to Burke, is small in scale, and something which is sublime is vast in scale. And you find that the activity produced by the two experiences is quite distinct. Of things which are experienced as sublime, Kant thought that these were done due to the activity of the imagination, and he gave mathematics as a special example, saying that to be able to imagine infinity as a whole is due to a power of the mind that surpasses any standard of sense. This is in his book, Critique of Judgment. And so I come to last bit I want to talk about, which is the experience of mathematical beauty and neural correlates, which I did with Michael Atiyah. It took actually 6 years in the making, because it turns out mathematicians whom I thought were fairly docile people are actually quite violent and extremely demanding. So Michael objected to, I don't know how many equations we passed the hat around to mathematicians. Michael objected to so many equations, so we had to change them, and so on, because some equations contain too much physics or too much something or the other. At any rate, so now mathematics represents, on the face of it, the extreme example of the experience of beauty derived from culture and learning. Because you can't, as you can with musical and visual beauty, you can't go up in the streets at night and pick up mathematicians and tell them to come to the lab and look at these equations. You have to go to a mathematics department, find people who are very experienced and knowledgeable about mathematics. And what we did was to give them 60 equations. It's just like the other experiments, 60 equations which they take home, they look at, and they grade according to beautiful, indifferent, or ugly. And they come back to the scanners, look at them again, and regrade them so that we know what the experience was when they were looking at them. And the experience, and the mathematical equation that most of them found beautiful is this Leonard Euler's identity equation, which links the 5 fundamental mathematical constants with 3 basic arithmetic operations, each occurring once, which Michael Atiyah, I believe, once described as the mathematical equivalent of the soliloquy in Shakespeare's Hamlet. And the one which most found, not all, most found not very good, is Ramanujan's equation expressing the inverse value of pi as an infinite sum. Now, if you look at the activity in the brain produced or that correlates with the experience of mathematical beauty, you find that it occurs in exactly the same place as the activity produced by moral beauty, by musical beauty, and by visual beauty, and that activity is parametrically related to the intensity of the declared experience of beauty. And by the way, it turns out, again, it was news to me, I mean, these mathematicians are fairly emotional people. They came out weeping some of the equations, and I believe that Andrew Wiles himself, when he contemplated the beauty of his solution to Fermat's last theorem, was fairly stressed emotionally. Now, this then raises the question of the relationship between beauty, or the uses of beauty. What is the use of beauty? And is it just there to adorn our lives, to adorn our homes, or is there something more to it than that? Paul Dirac in an article published in the Proceedings of the Edinburgh Royal Society of Edinburgh in 1933, wrote that the theory of relativity imported beauty into mathematics to an unprecedented degree. Before that time, the signal of the truthfulness of a mathematical equation was its simplicity. But since the theory of relativity, it is its beauty. And he always emphasized the importance of having beauty as a sort of an indicator that a mathematical equation was truthful or not. And if so, then one may begin to ask oneself whether the order, I mean, Dirac came up with positrons 4 years before, through his mathematical formulations, 4 years before positrons were discovered. So one wonders whether the beauty in a mathematical formulation, which, by the way, Plato thought was the highest form of beauty because he said it tells you something about the structure of the universe, is not actually telling you something about the way in which the universe is ordered. It is a question that I leave entirely to you and for discussion. No doubt many of you would object to that, but I think I would object equally as much to the separation of truth from beauty that is present in Bertrand Russell's definition of beauty, that mathematics, rightly viewed, possesses not only truth but supreme beauty, thus separating the two. And Hermann Weyl, when he says that when I work, I try to combine truth with beauty, but if I have to choose between the two, I choose beauty. I believe that the two are equivalent. Immanuel Kant, in his book, Critique of Judgment, asked, what is the pleasure that is derived from beautiful mathematical formulation? And his answer was, it makes sense. The question that I would ask is, it makes sense to what? Well, the only thing it makes sense to, the only thing it could possibly make sense to, is to the logical deductive system of the brain. And the logical deductive system of the brain chooses an equation as being valid and beautiful and satisfying if it satisfies that logic, and rejects it if it does not. And if you look at it that way, then I think the winner in this would be Keats, who said, truth is beauty and beauty truth. That is all you need to know. Thank you very much.
Thank you first for a fascinating talk. I really enjoyed that. It suggested to me another experiment that you might perform. I don't know whether it's possible to do this, but could you stimulate artificially the MOFC area of the brain, and would that cause people to change their mind? So if something they previously perceived as ugly, they might perceive as beautiful as a result of stimulating this particular area of the brain.
Well, it's an interesting thought experiment, but whether you get ethical permission for doing that. However, there is some indication that damage to that area of the brain leads to the syndrome of anhedonia, an inability to experience pleasure and beauty in anything.
But it would be interesting to see if the correlation was causal but not in the direction you expect.
Yes, indeed.
A second thank you for a fascinating talk. But these clever people in UCL and here in Edinburgh who do their brain research, are they going to get much further in relationships between the auditory and the visual and your whole idea of beauty? I mean, my question is really, is it worthwhile for those who donate their brains?
Well, I think as a medical student, I was dissecting other people's brains. I think it's absolutely worthwhile. The question of relating musical and visual beauty, of course, brought to a height by Wagner in his concept of the Gesamtkunstwerke, is extremely interesting and important. I think we neurobiologists are deficient in one way. We have not looked at the concept of time, because the musical and the visual and different categories of visual are not perceived at the same time. So the question is of how is everything bound together? And the answer to the problem of binding, I think, lies in studying things which are not perceived at the same time.
So you mentioned it's subjective, but how is there a neurological explanation for how perceptions of beauty change? I'm thinking of when the Rite of Spring was first performed, there was riots and so forth, or the Palace Salon rejected Impressionists because they were ugly, and then couple of decades later, regarded as the most beautiful things. So what's the sort of neurological explanation for that change in society?
You see, yes, of course there is a cultural element in the experience of beauty. But Clive Bell, whom I consider to be one of the greatest art critics ever, actually understood the problem. He acquiesced, admitted all of that, but said there is a skeleton that remains. When you strip it of all of that, there is a skeleton that remains, and it is that skeleton that allows you to have the aesthetic emotion. So if you want to understand the aesthetic emotion, go to savages, go to children, go to inexperienced people, but never ask an art historian. He knows too much. Right? And that is quite important. Now, mathematics is an interesting case, because mathematics, although, Michael and I have been discussing doing this experiment for many years. As I said, it took 6 years in the making. It was not entirely because he was a mathematician and I'm a neurobiologist. Mathematics is the extreme case of a situation which is dependent upon culture and learning. However, is it that dependent? Because once you know the mathematical language, whether you're from India or Iceland or Africa, you follow that logic. And I believe, I don't know what mathematicians think, I believe that the structure, the logical structure, logical function of our brains, whichever our ethnic or cultural background, are the same. And that is what enables us to understand the mathematical formulation.
Michael, for the last question before we go for coffee.
Microphone.
It's coming. It's coming. Coming.
Samir, magnificent lecture. But the point of my lecture, which was rather last minute and you didn't know I was going to say it, was, of course, that a man in the street or a child in the classroom can understand the beauty of mathematics by just looking at these nice, regular, solid pictures I was describing. You need no cultural information. Any child, any primitive, will understand the beauty of an icosahedron. And my point was precisely, you could take a child out of school, or a man off the street, or a savage, and they would all appreciate mathematics in that form. It is not necessary to have any cultural education to appreciate beauty in mathematics.
Yes. Well, I think this is very important, because you see, as mathematicians are a very exclusive and reclusive people, and people think that to access mathematical beauty is extremely difficult. But as you were saying, so it is not that extreme an example of beauty dependent upon culture and learning.
I'm going to call a halt at that point. We've got a coffee break, and there'll be more opportunity for discussions and questions then.